In this lesson, we're just going to practice our ideas about trig. So we're going to have SOHCAHTOA, we're going to have sine law, we're going to have cosine law. We're going to decide which one to use and when to use it, and then be able to use it. So I'm just going to go through the examples. My suggestion is you print them off, try them yourself first. See if you can do most of these. You should be able to at this point. But if you're stuck with one, come back and take a look at the examples. So first question. It's not right angled. So my first question I ask myself is, do I know a pair? Because if I do, I can use the sine law. In this case, I do. These two things are across from each other. So I know I can write down the sine of 123 matches with 72. Similarly, sine x has to match with 60. They're also across from each other. When I have fractions that are equal, I know I can cross multiply. So I can bring the 60 up, 60 times sine 123. I could bring the 72 up, but it makes more sense to leave it where it is because I want to try and get x by itself. To get x by itself, to solve for x, I need to take the inverse. The inverse of whatever 60 times the sine of 123 divided by 72 happens to be. I can put that all in my calculator just the way it is. You should get 44.34 degrees. There's our first one. Second example. First thing I'm looking at is right angle. If it's right angle, that means I can use SOHCAHTOA. To use SOHCAHTOA, I have to label my sides. Write down again up here just to remind ourselves. It's been a while since we've done it. Okay, I've got the opposite. I've got the hypotenuse. That means it's sine. So the sine of the angle I used to label, 47, is 20 over x. That's a fraction. That means I cross multiply. 1 times 20 is 20. X times the sine of 47 is x sine 47. I want to get x by itself, so I need to divide out the sine 47. And if I do that property, I get x is 28.7 degrees. Third one. Oh, it's not right angled. Can't use SOHCAHTOA. I look for a pair of things that go together. Now, it looks like I know 35, but I don't know the corresponding side. It's an x, so I can't use the sine law. That makes this a cosine law question. In the cosine law, the big letters that matter are the letter A's. Big A is an angle, small a is a side. Oops, B and C are interchangeable. So, reminder, our formula. Okay, I found the parts and pieces that I have. I have x squared. I've got 17 squared for B, 14 squared for C, 2 times B times C times the cos of the angle I used, 35. X is already by itself, so I can put it all right into my calculator the way it is. That'll give me x squared of 95.08, but I need to square root it to get my answer, because I want just x. If you did it right, you should get 9.75. Yeah, so a little bit of practice on SOHCAHTOA, the sine law, the cosine law. But these ones had diagrams. The tricks come when we don't have diagrams. So let's look at a more challenging one. A tree is leaning 5 degrees from the vertical. Actually, it's a 5-meter tree. To prevent it from leaning any further, a rope needs to be fastened 2 meters from the top of the tree at an angle of 60 with the ground. How far from the base of the tree must the stake be? So, we've got to put a rope on this tree to keep it from leaning over, because it's leaning just a little bit. How much? It's leaning from the vertical straight up and down, right? Vertical, it's leaning 12 degrees. There's my picture. What else do I, oh, sorry, not 12 degrees, 5 degrees. 12 from 5 degrees from the vertical. So what else do I know? I know the 5-meter tree, that's how tall it is. My rope is fastened 2 meters from the top. So in other words, the rope, or the length of this triangle, is 3 meters. I want to know how far from the tree must the stake be. There's my x. I know that we're making an angle of 60 degrees with the ground. Okay, so 60 degrees, not drawing the scale, don't worry about it too much. And I can solve this. But here's my big idea. The angle in the corner, right here, what is that angle? Well, if it was straight up and down vertical, it'd be 90. but it's leaned over 5 more degrees. So the angle is 95. And if I know 2 angles in a triangle, I can get the third angle, the one up here. That angle has to be 180 minus the 95 minus the 60, which gives us 25 degrees. And now I'm ready to do my math. What am I looking for? I'm looking for not SOHCAHTOA, because even though it had a right angle, the angle we actually are using is 95. So I'm looking for a pair. I know the 60 is across from the 3. I know the 25 is across from the x. This looks like a perfect sine law question. The sine of 60 matches with 3. The sine of 25 matches with x. It's in a fraction, that's cross multiply. X sine 60 equals 3 sine 25. I want to get x by itself, so I need to divide out the sine 60. That can all go in my calculator just the way it looks. And if we do that, we should get 1.46 meters. Done. The tricky part about that is the picture. The math is one of our basic problems, but these pictures are going to be our challenge. So let's try another picture. 2 cyclists leave an intersection at the same time at an angle of 41 degrees. In other words, I've got one person going this way, I got one person going this way, and the angle between them is 41 degrees. Let's move our picture of the way here. There's our triangle. One cyclist can go 17 kilometers an hour and the second 21 kilometers an hour. How far apart are the cyclists after 3 hours? So I wonder how far apart they are. That would be this piece. But it's after 3 hours. So if the first cyclist is going 17 kilometers an hour, well then this distance is 51 kilometers. Same thing for the other one. I'll times it by 3 to get my 63 kilometers an hour. Okay, I got myself my situation. What math am I doing? It's not right angled, so I can't use SOHCAHTOA. So for pairs, 41 goes with x, but I don't know x. The 63 and the 51, I don't know the angles across from them. That means this is a cosine law question. In cosine law, big A and little a are the sides that matter. So x squared equals b squared plus c squared minus 2 times b times c times the cos of my angle. It's like example number 3 that we did, right? A missing side. Put it all into my calculator, the way it looks, totally fine. You should get 1720.24, but remember that's x squared, so we want to square root it. And I got 41.47 kilometers. That's how far apart they are. Good use of the cosine law. Okay, let's try the next one. I got 2 more for you guys. A security camera needs to be placed so it can see 2 entry doors at once. The near door is 19 meters from the camera, and the far door is 23 meters. The 2 doors are 17 meters apart. What angle of view does the camera see? So the camera is going to look at one door and the other door, and we know how far apart they are. Well, that kind of looks like a triangle. The near door is 19 meters. The far door is 23 meters, and they're 17 meters apart. What angle do they see? That's where the camera is going to move back and forth. So I need to ask myself, SOHCAHTOA, is it right angle? No. Do I know a pair? I don't know any angles, so I definitely don't know a pair. That makes this a cosine law question. But I want to find cosine law for an angle. So I need to use the second version of the cosine law, the one that's rearranged for the angle. So what do I have? I've got big A, I got little a, B and C are interchangeable. So for my math for this diagram, it's going to be the cos of x equals b squared plus c squared minus a squared. Make sure a goes on the end. Over 2bc. Okay, do the fractions, top half and bottom half separately. We've got 601 on the top and 874 on the bottom. That's for cos x. I want x. Whenever I want to find an angle, I have to use an inverse. So I'm going to take the inverse of whatever this happens to come out to. Just use my fractions in my brackets. And I got 46.56 degrees. Okay? Last one. Jim. Jim has a triangular backyard with lengths of 27 meters, 21, and 18. His bag of fertilizer covers 400 meters squared. Does he have enough? So the question I'm asking myself is, how much area is my yard? Because I have 400 meters squared. That's how much area I can cover. So I need a triangle. 27, 21, and 18. Obviously not drawn to scale. The question I have to ask myself, how do I find the area of something? The area of a triangle in particular. The area of a triangle is base times height. So my height is right here. I need to figure out how tall this triangle is. I have the base. The base is 21. I need to figure out how tall this triangle is. So it has a right angle in it, but I don't know any of the angles at this point. So I need to find myself an angle. It does not make a difference which one. Let's find the one between the 18 and the 21. So I'm going to ignore the line down the middle for a second. We'll go back to the area in a second. I'm just going to find x. To find x, when I have three sides, there's a cosine law question, like the one we just did a second ago. Okay, so the cos of x equals b squared plus c squared minus a squared over 2 times b times c. So I use a fraction separately, top and bottom. On the top, I got 36. On the bottom, I got 756. We're going to take the inverse of that. And we'll get an answer like 82.27 degrees. Okay, so that's my angle in the corner there. Now, why did I want that? I wanted that so that I can think of this as being a right angle triangle. I can find the height of this triangle. So I'm still going to have side angle A over here. I still have this being 18. But I now know this angle over here is 82.27. The height of this triangle, the part up there, can be found using SOHCAHTOA. Okay. This is the opposite. This is the hypotenuse, because the right angle is right here, which tells me I can use the sine of 82.27 equals opposite h over 18. And we're going to cross multiply. So 18 times sine 82.27. Using our calculators, we'll get 17.84. So the height of my triangle is 17.84. Why did I want that? I wanted to figure out the area of my triangle. So reminder, area is base times height divided by 2. If we go back to the very beginning of the picture, our base is 21. We drew the height up the middle. So 21 times the height we got was 17.84 divided by 2 should give you 187.28. So the question is, does he have enough fertilizer? He had 400 meters squared. He only needs 187. So he has more than enough fertilizer. Okay, so today was just practicing problems. We need to be comfortable with all of them because they're going to get mixed together. We've got one more lesson left after this at the end of this unit, and then we're done. Okay, some questions to try. There's only 5 of them. Give them a try. The pictures are usually the hard part. If you can get the pictures, the math is, we should be getting pretty good at that by now.